field of point charge and its properties. A S1 point A at which the charge is q, and on the surface which is at a distance small r, there is a point charge q2 is placed, small q is placed at a point S2. At this particular point, the field or the force exerted, it is F1, and that due to this charge the force is F. So right. So we'll consider the figure, this particular figure in which at point S1 charge positive q coulomb is located. Second point S2 at which a point charge small q coulomb is located. This small q is point charge, okay, which is at a distance small r from the S1. So if we consider Coulomb's law, okay, according to the Coulomb's law, if two charges are separated by a particular distance, the force acting on either charge, okay, either or q or either or, so by Coulomb's law, the force acting on either or charge, so that force, let us say it is denoted by F, which is given by, it is nothing but the product of these charges, that is q and small q, divided by 4 pi epsilon 0 epsilon r into 1 upon r square. It is nothing but the product of these two charges divided by 4 pi epsilon 0 epsilon r into 1 upon distance of separation square. Okay, in this case, as it is spare, so its surface area is 4 pi r square. Okay, so where this epsilon 0, it is equal to 1 upon 36 lambda into 10 raised to minus 9, and epsilon r, it is nothing but the relative permittivity, so relative permittivity of medium, and you know that for air it is equal to 1. So this F is nothing but the force acting on either or conductor, either or charge. Okay, but if we have to define the electrical field at this particular point, okay, म्हणजे आता हा जो फोर्स आहे तो कुठपर्यंत एका पर्टिक्युलर फील्ड पर्यंत तो ऍक्ट होणार आहे, बरोबर आहे. सो व्हॉट इज द मीन्स, जेवढं आपण डिस्टन्स इन्क्रीज करणार आहे तसं जसं काय होणार आहे ती फील्ड कमी होणार आहे. तर या पॉईंटला जर आपण कन्सिडर केलं आणि हा जो क्यू आहे which is unit positive charge, it is very small. So if we consider q is very small, that is q is tends to 0, the electric field produced at q, okay, it will be given by q is very small, that is q tends to 0. So we can define the electric field produced by q at location small q as, हा जो q चार्ज आहे त्या q चार्ज मुळे या लोकेशनला असलेली इलेक्ट्रिक फील्ड हे आपण कन्सिडर करणार आहोत किंवा कॅल्क्युलेट करणार आहोत, अँड इट कॅन बी कॅल्क्युलेटेड बाय E इज इक्वल टू लिमिट q tends to 0, this force divided by small q. So if we replace equation of F in this particular case and if Q tends to 0, E will be Q upon 4 pi epsilon 0 epsilon r into 1 upon r square Newton. Why we have considered this Q tends to 0? Because see, we are going to calculate electric field at this particular point, okay, due to charge positive Q. So if this charge Q is not 0, it will disturb the field produced by capital Q. ओके, सो टू अवॉइड दिस म्हणजे आपण फक्त आपल्याला क्यू मुळे असलेली फील्ड कॅल्क्युलेट करायची, नॉट दिस स्मॉल क्यू. म्हणून आपण याला काय केलं, इट इज टेन्स टू 0 आणि त्या केसमध्ये फक्त क्यू मुळे असलेली फील्ड आपण कॅल्क्युलेट केली. सो राईट डाऊन द कंडिशन. The condition Q tends to 0 is necessary in order that Q might not disturb okay. So if we rearrange this equation, like if we are going to define this equation for Q, so Q from this equation, it will be Q will be, what will happen, 4 pi r square from this equation, 4 pi r square into, what will happen, epsilon 0 epsilon r into E. So Q will be 4 pi r square into epsilon 0 epsilon r into E. So in this case, in this particular equation here, what is 4 pi r square? 4 pi r square is nothing but the surface area of sphere. समझून घ्या. See here, in this particular figure, if we consider S1 as a center and if we draw a particular sphere, so its surface area, it is nothing but 4 pi r square. So from this 4 pi r square is nothing but the surface area of the sphere of radius r with center as a S1, and the quantity, this quantity, it can also be written as capital D. So let us suppose this is can also be written as 4 pi r square into capital D, where this D is nothing but epsilon 0 epsilon r into E, where D is equal to epsilon 0 epsilon r into E, and it is nothing but the dielectric flux density. So here we will get the, it's from this equation, I will rewrite it, that Q is equal to 4 pi r square into D, and D is nothing but dielectric flux density, which is given by epsilon 0 epsilon r into E. So here we will get the Gauss's law, and it is nothing but the surface integral of dielectric flux density over a closed surface equal to the total charge enclosed. This is Gauss's theorem. Keep in mind, surface integral of dielectric flux density, it gives total charge enclosed. So just write down the Gauss theorem or the Gauss law. It states that the surface integral of, so this is nothing but equation for charge in terms of dielectric flux density, that Q is equal to 4 pi r square into D, or we can say it is equal to 4 pi r square into epsilon 0 epsilon r into E. Now, so which are the properties of this particular point charge? So let us see the properties of field of point charge. So what is the equation of field of point charge? E is equal to Q upon 4 pi epsilon 0 epsilon r into r square. So the first property, the electric field intensity decreases rapidly with the distance from the point charge. See here, if we are going to increase this distance r, what will happen? The electric field intensity, it will get decreased because it is inversely proportional to the r square. So from this, as E is inversely proportional to the r square, from this we can conclude that E decreases rapidly with second property, that E is inversely proportional to the epsilon r. Okay, what is E? E is nothing but electric field intensity. It decreases with, yes, रिलेटिव्ह परमिटिव्हिटी. म्हणजे आता जर सपोज एअरची तुम्हाला माहिती आहे epsilon r ची व्हॅल्यू 1 असते, पण आपण जर अंडरग्राउंड केबल कन्सिडर केली तर त्या केसमध्ये इट मे चेंज. सो E inversely proportional to the epsilon r, it means it changes with change in permittivity. Third property, so what is potential at a particular point, or how we can define the potential? It is nothing but the work done against the bringing that unit positive charge infinity to that point. म्हणजे आता असं म्हणूयात की हा जो चार्ज आहे, this Q, it is at particular, let us suppose that it is at infinity. Okay, so the potential at that particular point, it can define as to bring this unit positive charge from infinity to this particular point. Infinity to कुठे येणार आहे? सॉरी, infinity to हा पॉइंट कुठे आता? at a distance r. Okay, so let us see, suppose third property, the potential at so the potential is nothing but to bring that unity positive charge from infinity to that point. So it is denoted by V, which is given by, it is nothing but the work done from infinity to small r. It is minus E dr. Why minus? Because it is against that particular force. So it is equal to, you know, the value of E q upon 4 pi epsilon 0 epsilon r infinity to r minus dr upon r square. So if you solve this, you know what is the integration of r square. So you will get potential V is equal to q upon 4 pi epsilon 0 epsilon r. See, याचा इंटिग्रेशन काय असतं 1 upon r square, so minus 1 upon r, so it will be minus minus will get cancelled, it is equal to holds. So what is equation for potential? V is equal to q upon 4 pi epsilon 0 epsilon r into 1 upon r. So this is potential. Fourth property is potential difference. So the potential difference between 2 points at a distance r1 and r2. So it will be V12, it is given by, V12 is nothing but the potential difference, q upon 4 pi epsilon 0 epsilon r into 1 upon r1 minus 1 upon r2 volts. And the last property of point charge, just write it down. I will wait for sign for particular time. And the last property is the capacitance C is equal to, you know, that q upon V. So if you place the value of q and V in this equation, you will get it is C is equal to 4 pi epsilon 0 epsilon r into smaller. This is fifth one. Okay, so this is nothing but the derivation of field at point charge and its properties. I will just repeat in within 2 to 3 minutes. So as I told you, we are going to see the field of point charge and its properties. So what we did, we have considered a point charge small q. It is placed on the surface of the sphere, which is at a distance small r from the point S1. At point S1 there is a positive charge q is placed. Okay, so this is nothing but the tangential force acting at point q, and this is nothing but the force which is acting at capital Q, that is point S1. So as per Coulomb's law, the force acting on either charge, it is equal to Q into Q, capital Q into small q upon 4 pi epsilon 0 epsilon r into 1 upon r square, where epsilon 0 is equal to 1 upon 36 lambda into 10 raised to minus 9, and epsilon r is equal to, it is nothing but the relative permittivity of medium, and it is equal to 1 for air. Now, as small q is very small, so we define the electric field produced by q, capital Q, at location small q, it is equal to, see, we don't want to disturb the field of positive q due to the charges of small q. So E will be limit q tends to 0, f upon q, it will be q upon 4 pi epsilon 0 epsilon r into 1 upon r square. Okay, so after doing some rearrangement, and we have to write down the equation for capital Q in terms of E. So what is Q? Q is equal to 4 pi r square into epsilon 0 epsilon r into E, and this particular term, it is denoted by capital D, so it will be 4 pi r square into D, and this D is nothing but dielectric flux density. Okay, so from this we can say that this 4 pi r square is nothing but the surface area of sphere of radius small r with center S1. So here we can define that the surface integral of dielectric flux density, it gives the charge enclosed by that surface, and it is nothing but the Gauss's theorem, Gauss's law. So it states that the surface integral of normal component of dielectric flux density over a closed surface equals the total charge in the volume enclosed by that surface. After that, we have seen the properties of field of point charge. So here E is equal to Q upon 4 pi epsilon 0 epsilon r into r square. So the first property is this E is inversely proportional to the r square. This r is nothing but the distance between these two charges, that is capital Q and small q. As this distance increases, this field intensity decreases rapidly. Second is E is inversely proportional to the epsilon r. So with increase in value of epsilon r, or by changing the medium, the value of E increases or decreases. Means if the value of epsilon r increases, it will get decreased. The next point, what is potential? Potential at any point, it is nothing but the work done to bring that unit positive charge from infinity to that particular point. So what is potential? Potential, it is equal to work done from infinity to that point minus E dr. Why minus? Because it is against the force. So it is equal to Q upon 4 pi epsilon 0 epsilon r infinity to r minus dr upon r square. After solving this equation, you will get potential V is equal to Q upon 4 pi epsilon 0 epsilon r into 1 upon r. लेक्चर झाल्यानंतर जेवण करे. The potential difference between 2 points at a distance r1 and r2, it is phi12, and it is given by Q upon 4 pi epsilon 0 epsilon r 1 upon r1 minus 1 upon r2. So these are the properties of that point charge, that is the field of point charge. And the last one was C is equal to Q upon V. What is Q? The formula for Q is, it is equal to 4 pi r square into epsilon 0 epsilon r into E. And what is V? V is equal to, or we can say directly in this equation, we can put it is equal to Q upon, let us say suppose V is equal to Q upon 4 pi epsilon 0 epsilon r into 1 upon r. So this Q will get cancelled, and finally you will get C is equal to 4 pi epsilon 0 epsilon r into small r. So these are the properties of field of a point charge.